and level 5 being the ultimate one that everyone is trying to achieve as well. Okay? Yes, school now? So this happens to be a generalized structure of self-driving car, a very generalized structure, a company neutral, a company agnostic structure. On top, if you can see a crazy looking machine there is apparently a LiDAR, which is usually used to steer your rockets, but that has been made compressed into smaller version that is being used in cars as well. The main functionality of the LiDAR would be, it just rolls around 360 degrees, it would throw out lasers, it would wait for the reflection of those lasers, and it would form an entire contour map about what exactly the surroundings of the car is. Then it would make certain predictions of what to do, when to apply a brake, or how to navigate within its surroundings. And the generalized help would be certain radars, certain sonars, all radio detection units, or any ranging and detection units would be there, and images would be there. The point was, until Tesla has entered this kind of domain, many people were dependent only on hardware sensors, LiDAR, GPS, high quality GPS maps. So that is the reason they were limited with certain geofence of area. In case they encounter something which is the models are not trained, then the cars would fail. That was the issue. But how did Tesla fix this? What did Tesla do to really crack it? So I have a question for you. How, as a human, do you measure distance? How do you know that this computer is a certain amount of distance from me? How do you know that? How do you do that? You don't have any probably inbuilt sonars or LiDARs like others in aquatic animals. You don't have that. How do you do that?
Depth map.
How do you do the depth map?
Our eyes are built for it.
Exactly. When you're able to do just from the vision, when you're able to do everything from the eyes, everything from an image. You have two eyes, you know the distance between both those eyes, and you know your body height, you know at what angle you're looking at, you know the tilt of your head. All this inherently your brain knows it. It is hardwired for it. And it can calculate distance. But if at all at this point of time, if you happen to lose one eye, then estimating the depth would be very, very, very difficult. The depth is estimated with the help of both of your eyes. If you lose one, depth estimation will be very difficult. And yeah, there are certain rules for driver's license. For people with one eye, it's very difficult for them to get driver's license too. So that is how it is. So Tesla here is basically trying to solve the issue of depth with the help of vision alone, not with the help of any costly LiDAR which costs around $10,000 to build a system. Not that. With just help of vision, Tesla is trying to solve the problem. And how is it doing? Something architecture similar to you, state-of-the-art YOLOs. There are other architectures built, but I am not going to go into depth of mathematics behind those architectures. I want you to understand that basic building blocks of deep learning when put together are able to perform miracles. Why not try something out? Why not experiment with that? That is what I want you guys to understand here. If you see, I'll just show you a rough architecture and I can also give you a data set probably to work on. So how Tesla is doing it? It is actually having 8 cameras. It is having 3 cameras in the front, each viewing at a different depth, each viewing at a different range. Something will have wide angle camera. Why do we need a wide angle camera? To notice the stop signs on board, to notice if someone is just running into you, some auto bumping into you, anything. That is how the wide angle camera is needed. And then you have the radar. Radar can view way too ahead into the distance. In case your cameras are occluded, occlusion in the sense. See, weather conditions won't be good all the time. Like you might have foggy weather, you might have some dirt bumped onto your cameras. That is the time when radar pops up into the scene. It will help you detect if there is any object that you have to put on certain brakes. That is what radars will do. And ultrasonics will help you to understand the near field objects. Very close within to your car, is there any object coming from all the sides? That is what ultrasonics here will do. And at the end of the day, as I showed you in one of the previous slides, Tesla system on chip. So what basically we do, you take images, you process it, but where? Do you process it within the car? Do you process it on a server somewhere else? Or just like Siri, do you say, hey Siri, and you process only that within your system, and everything else you say after it will be sent to the server and process there, and you get the results back. What would happen in a self-driving car? How much of it would be processed locally? How much of it would be processed in the server? Any guesses? Anyone? Any guesses? So basically, if you keep sending something to and fro to the servers, what would happen? There would be certain latency. You would have to have a strong network. You would have to send the images from the cameras to your server, and server has to process it, and you have to get results back from your server. And it could take certain amount of time. But what happens in the meantime if you say some object bumps in front of your car? What would you do? You would just wait there for your car to send some image to server and receive the input to stop, to put on a brake? No. An accident would happen in the meantime. That is what reaction times are about. Minimizing every single computation that happens behind screen matters, because this is a matter of life and death. In case your reaction time, your processing time is more, your car will bump into something else. To avoid all those things, every single thing, every single input that you see in here is processed within the system on chip on the car. And being an electric car, the system on chip has to be very efficient. Efficient in the sense of power management. If you see your general CPUs, anyone has any idea of how many watts your general computers would consume? Probably any GPU, how many watts your CPUs or GPUs would consume? The easy way rather? Any idea? Anyone else? When you're utilizing the state-of-the-art NVIDIA GPUs, it would consume hundreds and hundreds of watts when it's running on its full capacity. Upwards of minimum of 100 watts is minimum. Your laptop charges will be roughly around 76 to 96 watts. That is a basic thing. That much of amount of power you're consuming from an electric battery on the car, you can't keep that running for long. The range will be affected. But not. So what they did, they didn't use any state-of-the-art NVIDIA GPUs or something. They built something called the system on chip. Everything will be fabricated into single chip. Your RAM, your PC, your graphics card, everything will be processed into single chip. That is what recently Apple has started doing with their M1 chips. If anyone is following that, there is a breakthrough there. And yeah. So if you go there, these are all standard slides for how the cameras are placed. The three cameras each having a different view of perception. One is narrower, it gets wider. Next slide. And on the sides, you have roughly around 4 cameras. On right, 4, on right 2, on left 2. Why? You have to look for sideways intervention to your driving also. Something looking in your sideways forward or sideways backward. That is how, if something else is being bumped into your car, you have to notice. You want to have 360 information, whatever is surrounding your car. That is one thing. And when it comes, you have finally the payload looking cameras, back camera, that is all, that probably all the cars right now has a rear camera. But yeah, these cameras help. How do they help? It will come. It's not working. Previously, yeah. So not just cameras, this is what, as I discussed earlier, how the LiDAR, how the radar and ultrasonic sensors here work. And why not LiDAR? Why is Tesla ditching LiDAR altogether? That is something that I discussed earlier. Probably a 10,000 piece of equipment, which the same task can be done by your computer vision algorithms. You're using state-of-the-art deep learning algorithms to perceive depth from images. You don't need a LiDAR like a human to perceive depth from images. That is what is happening. State-of-the-art deep learning algorithms being applied to perceive depth just from the camera visualizations. That is what this entire Tesla architecture is being built on, and one of the best autonomous driving cars are being rolled out. So, initially, you have too many inputs, right? You have 8 different cameras. What would happen if you just start predicting objects from each of the cameras? What would happen? The problem is partial object prediction. What does it mean? Let us say you have a moving trunk. The camera on your side might capture only the rear part of your trunk. But would it identify that it is a trunk? Are the deep learning models well enough that can it identify just from partial object image that it is a trunk? No, not at all times. So you take input from all these cameras, you try to stitch up the input before providing it to any of the neural networks. You extract features from these images individually, and here by features, to speak in a much simplistic term, what a feature mean, what a feature is. Let us say there is this table. How do you identify the table? You notice some sharp features on it. It has certain sharp edges, certain sharp lines. That is what all features boil down, but at a very, very, very minute pixel level. I don't think much of deep learning math was covered to you. So me going beyond to what exactly a feature is, how each feature is extracted, wouldn't be much of use at this point of time. So just to give a rough understanding of what features are, how features from images are extracted, that is what I meant. In a human perspective, what certain sharp features that you can identify the object, something object specific. So if you see this 8 cameras, total of 8 cameras, the front 3, the side and the rear. All the images you try to transform into a vector space. So what do you mean by a vector space? Any ideas?
Vector space is a spatial space where we locate where we are. I don't know how to put up in words, but just to perceive the environment and act accordingly. That is where vector space comes in.
Exactly. So you're basically converting everything into numbers. That is all boiling down into how you represent whatever you're seeing there. Let us say you see some car coming in front of you, probably some of the images there's a car coming in front of each other, and see this is what is happening. Everything that you see in this image, there's a car in front of it, and this is what is being represented in a vector space. All the lanes, everything on the road is being transformed into a vector space. The deep learning algorithms involved here will predict whether to turn right, to turn left, everything within the vector space, not in the real world. So the initial step for everything would be to transform whatever as a human we see into a vector space. And then once you transform everything into a vector space, there the magic happens. There you employ state-of-the-art convolution neural networks, different flavors of it. So we just this you see is the starting block. ResNet is something you use a flavor of convolutional network, maybe something that you use to extract specific features from the image. Once you extract certain features from the image, you then go on to pass it to different pyramidal networks. That is something called as bifurcating. Again, whatever names I'm telling you about the networks, there are some fancy names that are being used. You keep getting more and more advances in it. There will be some basic flavor or variation of some fundamental networks, which probably in future classes in your academia you will be learning. But in parallel to that, I want you to read certain papers, not just limit yourself to the Rosenblatt's perception. Don't stop there. Read ahead. What variation is being used? If you read about CNN, how is it being used? Read about it. Something learning from what you are learning in academia, developing on it is very important. Now coming to the next part, once you extract certain features of it, you pass this through this chain of network that you see. This is what Tesla calls it as Hydra net, because the structure of it is something similar to that organism, so that is what Tesla calls it, Hydra net. Identifying not just the cars in front of you, but identifying different objects in front of you matters. A dog is bumping into you, a person is bumping into you, what would you do? That is why we need several different types of classification algorithms and several different types of regression algorithms there. What would you do if a car is coming towards you in certain speed? Not just the steering angle, but you also have to modify your brakes, you also have to change your speed, you also have to change which lane are you going to go into. All these things matter. And that is the reason you are having several classification regression algorithms, each 50 different models. This would be the rough architecture. Now the thing is, a simple Google search would bring you this architecture. A simple Google search, nothing much. You just go to a Tesla's website and you see what its AI network is. The director of AI at Tesla, Andrej Karpathy, one of the brilliant guys in CV domain, he will probably explain a narrative on how these things are working. But can you experiment with something? Can you experiment with something right now, not right now, but something at your homes? Not with the real world driving data from Tesla, which is not public by the way, but reflecting Hyderabad as least a wonderful data set of images on Indian roads, of driving videos for Indian roads. Can we experiment with something on that? Just for I'll come back to this slide. This is the data set we are talking about. Indian driving data set, right? This is has been released by IIIT a few years back. I want all of you guys to experiment with it. A simple collapse GPU would be good enough probably for not for the entire data set, but for part of the data set. You can experiment and see how the state of the art deep learning algorithms are working for self-driving. On the Indian roads, there are one of my friends who recently joined as a VP of one of the company. He has literally stuck multiple cameras to his car. He has he has incorporated certain devices and chips that can measure the speed, braking, everything within his car, and he literally collected a lot more data. And his experiment on self-driving car was brilliant. One of the startups directly offered a VP position to him just because of that experiment that he performed. It's not the end result of this. It's not how wonderfully your self-driving car has been, you're getting out. It's not always the end result. It's the experiments that you perform, the journey that you travel when you are performing those experiments. That is where you learn things. Learning is very much important. Once you go out of this knowledge, you will have to build things on your own. You have to learn a lot to sustain in this industry. Just go to previous slide once. So roughly this would be the structure of the Hydra net and what it is doing. Have you heard about this model training and retraining in your mechanical company? You guys heard? Training of models, retraining of models, building a model. Was all that covered in the theory of your classes? Okay. So the problem here is you can't. There are roughly around 1 million Tesla cars on the road as of now. If every single prediction is being happening on the fly within the car itself, how would you train a model? How would you retrain a model? You can't keep doing it individually for a million cars, right? So what happens is, on the day updates, there is a fleet of Tesla vehicles. 1 million Tesla vehicles on the road is collecting data every single minute and it is sending it back to Tesla. They are going through the data. They are understanding why certain data has been misclassified. Why certain data, the vehicle failed in making prediction. On all those things, they are training the models. Over 70,000 plus GPU hours for each training cycle of this Tesla. They train those models, and once the model training is done, they send the updates to that particular model on the way to the cars. Tesla fleet itself is their biggest advantage. Having 1 million cars collecting data on the road every day for you, that's not a joke. That is the reason, that is another reason why Tesla cars perform very well for autonomous driving. And it's not that the basic advantage of this Hydra net is at the end if you see on top, each head is a different model for prediction of different things. One would predict steering angle, one would predict your braking, one would predict an object in front of you. Let us say there is some stop sign, let's say there is some crosswalks, zebra crossing or something, and your model fails to predict it at certain times. That is where it gets retrained, and only that particular block can be sent as an update on the day to the fleet of Tesla. You don't have to send the entire model again and again and again. You have roughly around 48 networks, 48 different networks within the same full self-driving car chip, which predicts a ton of things on board. That's the beauty of it. What I would like you guys to try later on is with the instant driving data set. Try one prediction, probably just the steering angle prediction if anyone of here can try it and anyone can send me. That would be very exciting. Just predicting steering angle, not object detection, not segmentation, not all those things. Just predict the steering angle depending on the lane that you're driving in or acceleration, something. Single attribute prediction would be very beautiful. So there is one small thing in this. Within the network, it's not always about predicting something based on stills image or single image. It's not always single image prediction. There could be a problem with single image prediction. Why? Because as a human, what do? When we are driving somewhere, we see on the boards on the side, there is something that is away or we have to turn left somewhere or some sign. And later on, we have to take the decision. We have that sign within our mind. And that is because we have a history of images and history of video within our mind. And that is what even Tesla does. It stores certain amount of history within the models. It might be in span of milliseconds, because even a second is very costly in terms of life. So, few milliseconds of history is stored, and as and when it is needed, it will be used. Let us say you are driving, you will be seeing so much of input goes to your right, so much of input goes to your right, to your right. But you discard all those things and you carry on with important information like stop signals, signs, all those things. And you carry forward those important information. That is what these architectures are trying to replicate. Something that we do as a human in real world, something that these architectures are trying to replicate. So again, what I would like to tell is, someone from anyone, if they can experiment with the instant data set, that would be brilliant. You would learn a lot with just one project, what you wouldn't learn from 10 different assignments that you work on just the same thing. No offense to anyone, but yeah, that is a fact. You learn so much from one end-to-end project. And so this is the full self-driving car chip that I was referring to earlier. And the major reason of they building it for themselves is for power, budget, and efficiency. You can't have chips that consume more power on your electric cars. You can't have chips that have so much of latency. If you try connecting different chips, there will be a problem of latency. But if you build an SoC, a system on chip, and everything is interconnected within the same chip, speeds will be miraculous. And yeah, these specific small chips are designed in such a way that they create the computation speed of dot products. If you see any stylish network name, any network name that you try to utilize, end of the day it has to back propagate the weights. If you let's say that you back propagate the weights. End of the day it boils down to dot products of numbers. And that if the chip is able to do it much faster, your latency would decrease and your reaction time of the car will decrease. So that is something very important. And in a similar way, Google Colab has introduced something called as tensors, TPUs. Something that you can work on when you specifically using TensorFlow, the type of deep learning framework from Google. So this probably will go down this. You can just go to the AAA Handbag website and you can download self-driving car data set and you can experiment. You don't need the exact domain or name. Alright. Yeah. So after that, like to start something called as judging book by its cover. Usually it is the opposite, not judged by book by its cover, but rather India judging book by its cover. Basically, your phones are allowed to say, right? So anyone having Amazon app just can open up that app and try something and searching with an image. Just within your phones. You all can take out your phones actually. No phones? Phones are not allowed. Even having phone. Officially not allowed. Even having phones are officially.
So the point is, are you allowing my phones?
It's fine, you don't have to get taking out a phone, right? No, not a single phone, you have one. So just open Amazon app if you are in that and try for image search. And you see something, what's happening there? What is happening? Can you describe? What is happening when it's loading?
It's having
Dots. Okay. You just show it on public data, you can share the phone. You can just share the phone around you. Has anyone tried out that feature before?
yes.
Tried out? Anyone who hasn't tried out? Raise your hands. You know, as a private image search. Using another hand. Everyone? Okay?
It's the first time I'm doing it.
Cool. Many people have tried it. Cool. So, behind the screens, what exactly is happening? As I told earlier, it's identifying features from the images. Small features that you can feel they are significant enough. The same thing is somehow built by Google as well, but the one with Amazon will be much faster. One small reason for it would be it has a narrow search space. Amazon just has to search from an index list of items within its store. Whereas Google, it's an unlimited storage space, like it has to search any number of different things. When you have a restricted search space, your search results will be much faster. And that is what is happening with Amazon. So what this particular case study is about is, basically, I would like to scan a book with my phone and I know the reviews of the book from Goodreads or sites like that. Has anyone here built any web scrapers or any scrape data from the internet before? Any student, anyone? You guys? Anyone who's worked with web scraping internet? Okay. So, web scraping is basically you are either illegally or illegally downloading information from some website. Boils down as simple as that. So what does websites do? Certain websites allow information to be downloaded legally. This is my site, this is my information, whatever you want to do, you do it. That is what certain websites are. But what certain other websites do is they block it. How do they block it? Let us say, to build this, they roughly downloaded around 2,07,528 images of books from Amazon. There was no single data set, I just had to scrape them. I wanted just images of those books. I had to scrape them. There is something beautiful for each and every book called as ISBN number, unique identification number for every book out there. So, in Amazon, you can frame a URL with the ISBN number at the end and you get the page for that book. And once the page loads, all the HTML, CSS, all the entire page loads into your browser, you can actually download the image wherever that particular book appears. And you can run a bot, you can run a script. Script is nothing but you just simply loop it in, just take the ISBN numbers and you try to download all the images. But what Amazon does is, if it is getting back-to-back requests of such page loads in a very short span of time, it blocks it. It blocks your bot. Or it will reduce the speed of the bot to very ridiculous number of speeds. It's like you're working in MBBS and GBBS speeds and it would be reduced to bytes per second, kilobytes per second. That's useless speed when you're downloading an image. And just imagine you have downloaded 2 lakh images at that speed. It took me roughly around close to 3 days, 2 to 3 days somewhere to download all these images as I was being blocked multiple times. But yeah, that is some way that you can save information from the websites. And coming to the review, I'll tell you the start part, I'll tell you the end part, middle part, you just go through, I want different ideas from this. Start part is, I take a picture. I take a picture from my phone, it will identify the book, and I have DP with it. All the images of the books are stored along with their ISBN numbers. Each and every book is stored with their ISBN number. So once my query image matches with the image in my database, I fetch the ISBN number of that book. And next, what do? I query a site like Goodreads or even Amazon list to get the review of it. If Goodreads forming URL is much better and it doesn't block bots. So what you can do is just goodreads.com/ISBN number is equal to that particular book number, and you can get all the book details. And app was built on this, and this was done roughly around 6 years back with a certain set of architecture and using OpenSea. But what has developed within the 6 years is the way you extract features from the images. It's not any more classical computer vision, but you have state-of-the-art deep learning models to extract features from the image. And that is the beauty of development that has happened in the last 5 to 6 years. So, my question to you on this would be, how would you build a system to search, let us say, 1 million images? I have a query image, How would you search 200,000 images, 1 million images? What would you do? Do you compare every single image in your database with these features? Left case? Clustering? Okay, that is a good idea. And let us say, even after clustering, you still end up having 200,000 images. Out of 1 million images, you form clusters, 4, 5, 6, n number of clusters. You have hundreds of thousands of images within each cluster. What would you do? Still, it's something of order of n. How would you reduce it? What would you do? Anyone can come up with a general approach. The point here, the system to be built is all I want to do is take my phone, click an image. I want the details of all image. I want the details of the book in that image. What would you do? Something you need not use deep learning. You can just give me simple answers, like any system architecture that you can come up with. Need not be deep learning. Sir? Any ideas? Okay. What would be the problems with that? How would it be different from clustering? How vastly would it be different from clustering?
Problem with hashing is it will generate more keys. Database will be more.
I don't have an issue of space. It's Amazon.
Processing will be the issue.
Processing is fair.
Converting numbers, encoding and decoding will be an issue in action.
Okay, but that would be an issue.
These are it's not my domain.
Any other cases? Any other cases that can reduce the search time? You just took a picture, right? How much time did it take? Few seconds? What? Any idea what is happening? Any cases? Any hashing, clustering? That's a good case. Any more cases? That would definitely reduce the time from order of time to this cluster. It would reduce the time. But what is another problem with that? You still end up having certain number of images in a cluster. Again, you have to go through those images. Any other order. Take 5 minutes, probably 10 minutes, discuss among yourselves, and some form of system architecture that I can get from. Take some time, take 5 to 10 minutes, discuss among yourselves. Probably possible avoid those. Let me just bump this up a bit. Any group of persons, any team that you guys can form probably internally, that comes up with a decent enough solution for us, probably in the next 15 minutes or so, I'll give them access to an online machine learning course for the next 1 year for free of cost. An end-to-end machine learning course which involves deployment, deep learning, machine learning, everything. So for the time as of now, it's roughly around 15. So I think that it takes the time to give it. Not great. I want you guys to discuss with yourselves.
Actually, 3:45.
Yeah, we can probably go for a break after 3:45 is a break. 3:45 we can go for a break.
3:30 up to 3:45.
When is the break?
3:35.
3:35 is the break.
3:30 to 3:45.
Okay, so next 10 minutes before the break, whoever comes up with a good enough solution, we'll probably push the break 10 more minutes, probably 3:40, 10 more minutes to push the break. I hope I get some good enough solution from you guys. And any Google searches at all, if possible, avoid it. If it's a Google search, you can make it. Sir, wait,
Option. So I'm pressing. Yeah, speaker.
Sir, can we use writing algorithm like implementation system?
Thank you. ఇప్పుడు ఆమె చేసేయాలంటే ఏమో మీరేం
ఇది డిస్ప్లే అవుతుంది సార్ ప్రొజెక్టర్ మీద
ఇదైతే
ఈ డిస్ప్లే అయితే బ్రేక్లో వాళ్ళు ఫిల్ చేస్తారు సార్ ఫిల్ చేసే వాళ్ళు
ఇదే కదా
అదే సార్ అదే సార్
ఒకసారి చూడండి
ICAI PPR FB1 teneural.com అంతా సేమ్ ఉంటుంది సార్
Any of those? How many of you have come up with any of those? Just show of hands. Who has come up with some approaches? Show of hands. Any of those? Don't hesitate. There is no split right and wrong. Everything is a perspective. Right and wrong is always a perspective. So don't hesitate to listen. Anyone with some approach, some basic approach. It might be a small step also. Anyone with some just show of hands. Anyone with some random ideas, anything is fine. Raise your hand. Raising your hand. Yes, no, maybe. Raising. Okay. Yes. Need more time to figure it out. You had some doubt, right? And you probably can raise your hands. You were very good. Okay. Yeah. Your approach also, you can discuss your approach. So you can start with
Pixel comparison.
okay. And how will you do that?
Taking the internet, divided in
Same thing, see a bit more about it.
So by taking the internet and divided into a smaller pixels as a matrix and we generate histograms.
Okay. Okay. So you let me reframe it. So you're taking basically, I have 1 million images, 1 million books maybe, and I have query book. You're telling me you calculate the histogram or something like that for today's quantities for the query, and you compare that with 1 million of the images. Wouldn't it increase the success? Probably automatically having 1 million comparisons.
They have a lot of state of the art fields.
That's a good answer right there. But yeah, partly that is correct. Not another part of it, but your instrument part, that's one approach. So
We get more for half year.
but yeah, even coming up with decent approaches, I definitely give access to the question. So anyone else? You raise your hand, somebody else here? You do.
Similar to YOLO algorithm.
Okay.
So using the YOLO algorithm.
Okay, and how would you picture that in with this? How would that reduce my search time? Except it's Amazon and it's having massive servers apart from that. Any other way? Any other way that can be reduced? Any other trick? Something to reduce the search time. Maybe like earlier you said you would cluster.
You can combine it with clustering and then
Okay. You combine it with clustering. So initially, so tell me the entire approach.
initially it is divided into clusters.
Okay.
And then when the search comes in,
Okay.
then it picks one cluster and then does the YOLO approach in that cluster and then get the
Good. That's a good approach. Good. Anyone else? Come up on the side. Good. Yeah.
Yeah, we can perform k-nearest neighbors. Instead of clustering, if you perform clustering in one cluster, there can be layers of images. Instead of that, you can take k number of nearest. This is same to the one you said, same pixel idea.
So tell me the entire approach. I have a query. I have a million images in my database. What would you do?
Yeah, actually, searching text is through pixels itself. Instead of clustering, my idea is k-nearest neighbors.
So
Instead of having a large group of images, we can take k number of nearest images and
So you're telling me you map the entire 1 million images, the pixels, all of those pixels of those 1 million images into a higher dimensional space, and there you will do K arrangement. Something like that? Okay. That is also partly correct, guys. Partly correct. In other purposes, we have some. Yeah.
We can maintain cache. Most recent searches we can store it and we can search in the most recent ones. Or we can use hashing for assigning hash code for the cluster.
What do you mean by a hash code?
Like different clusters, we can divide the whole data set into whole data points into different clusters.
Okay. You have 1 million images clustering. Anything apart from clustering? I'm getting clustering now. Anything apart from this?
Like in searching in cluster also, this cluster should be searched with the problem. So we can assign a hash code for that.
Okay.
Or like most of the
The same as picking a cluster, right? The same as picking up a cluster, right?
but most of the time when we search in Amazon, if we search from same network, we'll get faster access to it.
That's all cache.
Or most recent searches we have done, it will be based on that.
Let me rephrase that. How would you reduce the search time for book? Okay, you're searching some weird crazy book that you found. How would you reduce the search time? Not just the recent searches. Even if it's a recent search, if it's just from your data, again it falls down to the same thing, right? You're searching just the previously searched item. It fetch results faster. But for the first time you searched it, again it would be the same thing. But it's a whole different concept, how the searching happens, how the recent searches are found by Amazon. There's a whole different concept again. What kind of network activity is using a ton of different things.
Again, it should be hybrid kind of architecture.
Cool.
Because of it's supposed to be guided by the objects, clustering, image pixels, and object detection. So hybrid structure is supposed to be.
Something like multi-level searching, you reduce the search at each level with different sorts of algorithms. Okay. Maybe from 1 million, like you said, you cluster, you reduce it into 200,000 to 50,000 points in each cluster. Then again you try out something that within the cluster you reduce it. Then again you try out something within the cluster you reduce it. But do remember, there will always be a trade-off between the speed of the algorithm and how accurately the algorithm is achieving the results. You might miss out on certain searches, certain results from your search if you aim for speed alone. Okay. So multi-level matching, that is a good thing. Any other approaches here? Okay. How would you mix them both?
Means we will extract the features of any figure or any image.
Where image you have features
First
extract.
we train the data.
Train the data on what?
Means we take a large amount of data sets for books like this.
Okay. Okay, let me make it simple. You have one query image. Let us talk about it as a query image. Okay. And you have 1 million images to search from. Let us say in simple terms, it's your train data, right? In your terms. So how would you frame the problem answer? How would you frame the answer to this problem?
Means based on it will classify with that our requirements and our features, it will classify our requirements. So by that the books will be reduced. The different books will be reduced.
How would the required books be reduced? Let's say you're telling me that you like what I understood from your point is, correct me if I'm wrong, you will extract CNN features from the query page. Okay? You said something about the train images which I didn't get. So yeah, what is it? You extracted CNN images from your CNN using some CNN architecture, you extracted certain features from the query page. What do you do next? Tell me the flow. Yeah, tell me the flow. Like, what do you do after it? You extracted features from your image, query image. What do you do after it?
Can I explain an example?
Sure, definitely.
Means if you have like flowers or something, you like species, someone flowers or species. Means if you give any flower, this is the flower of all the flower values from the data set. Then it gives the more accuracy And what is the flower and what is the shape of it? Will be reflect.
You don't have any of those. I guess probably you're coming up with this iris dataset example. Something like that, something based on iris dataset. Virginica flowers and all those things, classification of that, something similar to that. There, you see, you're applying random forest or whatever in that case. There, you have the sepal length, you have the petal length, you have the width, all those things, right? Here, you are, it's like a black box. In case you're using CNNs, you're extracting some features. What each feature is representing, that's a whole different story. You picturizing, that's a different thing. You just have some vectors, you just have some features. What do you do? There is no
To act after actually, it's not a label data. There is also the data.
yeah.
There is no label for the data. If you have label, then you can apply classification.
Yeah, that's a point. Then you have this Virginica, you are clearly labeled data and you're training on it. Yeah, nothing is labeled. Here is something like close as much. But yeah, good try. If it's labeled, that would have worked. If the data was clearly labeled properly, that would have worked. But yeah. So far the approaches that I got, one is clustering. The other approach you guys is to histograms research and you multiple matching. Three approaches and you nearest neighbor approach. There is a slight variation to that approach, but that is used. Okay. And total 4 approaches. What was your approach? You add some hashing, right? You add some form of hashing where it can be found and reduced. So total 5 approaches. Any more? Any other approach? Anything else that you want to discuss? You add something, right? Nothing? Okay. Cool. So it's a mixture of all these 5 solutions. And again here, this system can be further much optimized. Let us say, I tell you a problem with your PNL approach. Have you got something called as personal dimensionality? Heard it, and that occurs with PNL in higher dimensions. Especially when you are using this something like equidistant or something like that, especially occurs for higher dimensions. The point of nearest neighbor fails when all the neighbors are roughly for the same distance. And equidistant for all the neighbors, if that issue, if that scenario occurs, point of nearest neighbors fails, right? How would you pick in that case? It would be a random search. Randomly you have to pick. So there is that one issue in higher dimensions. If you do the nearest neighbor matching techniques, there are flavors of it, there are improvised versions of it. There is something called as plan, nearest neighbor matching technique. Localized, there's something called as plan, and there are advanced variations of that. We'll discuss that probably post the break. Most probably, if you're waiting for the break, post this, probably we'll run some code on how this works. But the thing is, I want to show you how CV was operated, computer vision, the classical computer vision. If you get the flavor of classical computer vision, you would appreciate how many things were built just on basic stuff, basic math, no deep learning, no GPUs, just on basic math, how beautiful the computer vision was done. And later on, I want you to change certain things in this code, change certain things. Like let us say you're trying to extract features with CNN. Who's trying to? You are trying to feed and someone else. So you who told us CNN? Yeah. Okay. So CNN is feature extraction. Here we will not do any feature extraction with CNN. I will show you something which is predated to CNN, the fundamentals of why CNN has occurred. And I want you guys to replace this code with CNNs and see how much efficiency you guys are getting. So, I will explain the code that is written. I just use the notebooks to share you all the details. What I want you guys to experiment later is play around to reduce the search time. And your histogram is the very first level of reduction in the search time. Histogram would give me a rough estimate of how many number of pixels are there in that particular thing. I'll explain next one about the course of grade and all those things. But yeah, we will start with histogram as level 1 matching. We will eliminate certain results. We will eliminate certain data from our training set in level 1 using histograms, and then we will have a level 2 matcher, and then we will have a level 3 matcher. In the third level, we probably narrow down on the exact result, and we will use that to fetch reviews from Goodreads or Amazon sites like that. And what the task in that will be, I'll discuss it later. Okay, so let's go for a break now and come back in 15 minutes. How long is it? 15 minutes?
15 minutes.
15 minutes, right? So, for the time, roughly 3:45. So, we can now be here and go.
Guys, wait for a minute. We'll display a link on the board. You need to give feedback.
And there is one more thing I would like to share the 4 files of what I'm executing here. Not just me, I will try all of them to execute in the collab also. Just collab, they did not install anything or something.
After
Yeah.
break.
Yeah, so after that.
Students use this link to give the feedback. It is mathematic for all students.
Once if you are submitted, then show it.
Thank you.
Thank you.
Okay, students, settle down. All students, settle down, please. So now we are going to have a small informal interaction with sir. Apart from his technical expertise, we should try to extract every bit of information and experience that he has. So we are going to have a small informal interactive sessions with him. Please pay attention. Sir, yeah, Mike.
There is one link I want to share from the research. Sir, share the link both Kodar and the share the
Where is the speaker? Check if it is. Can you check if it is? Check if the mic. Blue color mic.
Okay, it's working.
No.
Am I audible to everyone? So the first question which I have for sir is that apart from technical knowledge, an engineer requires other skills also. Just recently I was reading a book called Atomic Habits, which spoke about micro habits you can form that will change your life. On a similar vein, I would like to ask sir, what are the habits which a successful engineer requires to succeed, and apart from that, what mindset do they need to have for success, sir?
So starting with the word success topic, like it's not working successfully. I don't know. It's working.
Okay.
Right. So coming to that question asked, frankly speaking, when I was in college, I missed out on a lot of things. It's not just about having fun, it is equally important. Not just academia, that is a part. But the thing is, read, guys, read. Like you read Atomic Habits, right? That is one very good book. Over the last few years, probably post college, I've read 200 plus books. I built a home library for myself where I converted an entire company into a library for myself. Reading gives you a lot of knowledge. See, there will be two things. One is going into depth in one particular field and having knowledge of many different things. That is also equally important. You will get a this is the case, this is where this is the so this is the right time where you can get enough information on different things. Tons of different information. Yeah. So read from a wide variety of sources. And see, it's not just about social media, it's not just about blogs. Back then, there wasn't so much of Instagram for us. Don't think of me as a dinosaur though. Just few years senior to you, probably 7 years senior to you. Yeah, so it was not about too much of fake Instagrams or too much of fake ideas being propagated around. Just take a book, go to a coffee shop, spend some time for yourself, read. Make sure to read every day. Some few pages a day, maybe 10 pages, 20 pages, start a reading habit. And trust me, and it was, he was just talking about communication skills and all these things. Trust me, I couldn't frame a single sentence in English back then when I was in college. A single sentence in English, I couldn't frame it. I had so much of this phobia kind of thing to speak properly, couldn't find a single sentence. It develops gradually. Nothing happens overnight. Even the company that I was working at, it didn't grow overnight. It took us 4 years, 4 scrutinizing years. There was no Sunday, there was no Saturday. We worked the asses off to be frank. And it comes gradually. Prepare. It's not just reading about memorizing books or something like that. Take some time for yourself. Any topic, right from philosophy to science to fiction, anything, read. That will broaden your mind. Your vision, your mind, your thought process, everything shouldn't be narrow. You should be ready for change in every aspect of your life. That is how I built myself from scratch. There wasn't any single mentor for me. There was this one thing I always do. If I like someone, if I admire someone, I try to pick some quality from them. And to be frank, coming about books, and that's why I'm speaking so much about books. There are so many great people in the world. Frankly speaking, there are thousands of great people in the world. They have seen so much in their lives, a lot of valuable experiences in their life. The thing is, when you have conversations with them, they'll tell you a lot. They'll tell you what they've seen. If someone made some mistakes in their life, you can learn from them. You can probably make new mistakes. Why make the same mistake that someone made? Make new mistakes. That you cannot have a chance. And you cannot simply go and have coffee with Steve Wozniak probably. That guy was the first one who invented this entire, discovered this entire Apple computers. I don't know how many people here know about that. So only Steve Jobs that gets projected out, but the brains behind that was Steve Wozniak also. We can't have conversations with each and everyone. We can't have conversations with John and John. It's not possible online. But there are books that they have been written about them. Either biographies or autobiographies. There is a difference between two. There are books on them. Read them. It's like having a conversation with them. Understanding what they did in their life, how they failed massively. You royally fail, that's fine. You learn something. That is important. Don't have to see closed doors. See something open opportunity at every step in your life. Right now, probably you're at the end of the third year. Third year, so it is a good opportunity. You will have placements going forward. Prepare for that. That is very important. But once you're getting more placements, getting placed, all that is done, take some time for yourself. Start developing reading habit. Read few pages a day. Not online blogs, not blogs, not some Instagrams, not some fancy news articles. Take a hardbound book. Okay, people who don't like hardbound books, take a Kindle. Read. That is how you develop your vocab. That is how you develop the primary perspective of your knowledge. Okay. So one habit I constantly developed over the years was reading, and that helped me pick up things. There is one thing about me that my friends always tell me, give me anything, I can read it for 5 minutes and I can speak about it for 1 hour. That is always my colleague here tells me. And one interesting aspect about the colleague here, that guy comes, I'll tell you after this next question probably. There's something interesting about him. So yeah, reading, pick it up. That will help you read research papers also. You can skim through research papers. Like you probably have a you're skimming through research papers. That will give you a wider perspective how things are doing. That is important. Reading helps. It's not just some audio lectures, it's not just some video lectures. Read something. Develop that habit. So one thing that I will tell you is reading, which I couldn't in my engineering when I had time. Post engineering, once you're out of this college, remember and mark my words. Your time will not be in your hands because someone else will be paying you for your time to work for them. Once you step out of this campus, once you start earning on your own, your time is out of your hands. They will tell you 8 hours IST of work, but IST, it's not Indian standard time. According to the companies here, most of them, it is Indian stretchable time. So, post office hours also, they will bug you for working. They will ping you post office hours, it won't be day, night, nothing difference. But that is fine. At what cost? Is health a factor? Are you learning something or are you just doing the same thing again and again? Working for a big player and doing again and again and getting a hefty package is one aspect of life. Taking a risk, running a startup, getting your hands dirty, learning 10 different things is something different. Right from the website that my company had, I built it. I was a machine learning engineer, I was a software developer, I built the site, I built the backend cloud service for the site. I didn't know anything, man. back then when I started. All I had was really good mentors who would teach me and some books and online resources. Coming to code, your best friend who is Stack Overflow is probably figure out in the next few minutes when the code you're running will fail. So yeah, that's it.
So, thank you, sir, for such a comprehensive and detailed response. How many of you are in my soft skills class? Raise your hands quickly. Okay, most of you. Put your hands down. So, sir here is a live example of why you should step out of your comfort zone. Why it is important to not just be satisfied with the academic knowledge you get from your textbooks. So, I hope everyone here gets inspired from sir. I would like to now hand over the stage back to sir so that we may continue the session. Sir.
Sure. So probably we will get started with the code part, and yeah, just before I forget, 5 or 6 people of you who are answered earlier, once this session is done, please meet my colleague over here. He will give you access to the course on machine learning, deep learning and deployment on it for the next 1 year, complete 1 year free of access. Okay, and the other thing would be something about my colleague and friend here. I met him probably close to 4 years back somewhat, and he is your senior. He is the reason I'm in this college as of now. He asked me to come to this place to give the best of the content possible, to give industry-related case studies because he wanted to give something back to the alma mater. He is Manoj, and yeah, probably he'll speak to you guys, he'll interact with you. He may probably explain you certain pieces of code too.
You guys consider practical choice.
So yeah, he is one of the hardest working persons that I've met in my life. Initial days when I met him, he was just some college graduate working. He was placed in multiple companies here. One of the companies he got into was OpenText. He came out of it. He took a risk. Once the startup that we were working in started, he pitched in, came in, and many people weren't willing to take a risk with their career at that point of time. Only so that he realized he can learn a lot more coming out of that place. He came out, he pitched in. For the last 3 years, he has hardly taken any holidays for himself. He has built the company from scratch with us and has learned a lot in that journey. So probably he'll be in a better place to address you guys probably at the end of this workshop. So yeah, let's get started. Let's get our hands dirty with some code. There is some shareable link that is someone was sharing. It's in everyone's systems. It's sent or? Okay. You can probably type to screen. Someone has done the correct.
Take down the number. 87. Share the video.
I'll just take a minute here, guys, till you set up your systems with this website. I'm guessing most probably you will have to replicate this data set and code with your personal Google accounts for it to work properly on a system. We'll see how it goes. We'll be executing this code line by line parallel. We'll see how it goes. Just a quick question for all of you. I need a show of hands for this. How many of you here want to execute this code cell by cell with me? And how many of you want me to just give me an overview of this code by me executing it and explaining it? There are two options. So first option, executing cell by cell with me, a show of hands. You don't have to hesitate. Both approaches are totally fine. You will be given access to all this code. Everything will be with you. And later on, after the workshop also, we can interact. Since there's a bit more after this part also about the regulator systems, in the interest of time, the code execution, I may probably speed it up a bit. Okay, just so that you can see this code within your computers, let us put it that way. And if it's okay with each and every one of you, then probably we can speed up this code execution of it, and we can continue the recommended systems part. And then we can experiment with the code later on. You will have the data with you, you will have all these things with you, and probably, yeah, you will have some good pictures of belongings to that. So, yeah. So it's 5 minutes, it's period for the code execution. Or, something that I want to show you is probably, I don't know, it's just a rough. Yes, most of the functions used in it is sort of mix and match of the data we have and also pre-deep learning era stuff. I am explaining pre-deep learning era stuff only because there is a lot of experimentation and there is a lot of skills that you can learn from it. Just going to the documentation of it and rather than just black boxing the deep learning part. So one of my founders used to say this word, I help you and teach you how to learn. Learning how to learn is something that's slow and progress. Sort of confusing, but yeah. You're stuck somewhere, here in the college, you have your profs to help you out. Outside, when you go out of the college, when you're working at a company, it's not always the same thing. You're left to do the same thing. Either you do work that has been existing there, carry work from your seniors, or in case you want to improvise on those things, you want to learn those things, there will be very few people within the company to help you out. Because at the end of the day, it's just a chain, it's a thread. Everyone working just for his own salaries and all those things. So they going out of their way to help you, to teach you, will be less. In such cases, I want you guys to be in a position to figure out where you have screwed up the code. How to use tools to the best possible extent. Talking in terms of code. So, we'll wait for a couple of minutes till everyone's screens have this code on. Show of hands, whoever hasn't this code set up on the systems. It's not yet set up. Show of hands, only for people who this code is not yet set up. Anywhere, if you guys are facing any issues in the initial setup, our colleagues are doing
and after that, open the collab. Okay.
Just go around and see this flow with the meeting. It's taking more time for you guys to set this up on your screen. So probably start. I'll show you the study. So guys, rather than downloading the entire folder and again uploading it to you, in the interest of time, since we are getting closer to the seminar ending time, in the interest of the time, we'll probably skip the folder copy part. I will run the steps here, go through the code in your system, okay? At the end, I will show you how to, one minute I will show you how to download the entire folder, put it in your class, and probably execute it. But right now, just follow the code flow, okay? If you can open this page, the initial icon below. So, yeah, my colleague there will be running steps. So, how many of you here are not familiar with Google Colab? Raise your hands. Raise your hands completely? Yes, no, maybe? Okay. So, earlier, okay, of all the people who are not familiar with Google Colab here, did you run any of these algorithms earlier? If so, in what? First time, right? All of you is the first time running this algorithm? First time. For you? First time, right? So, basically, this is executable Python code. Nothing apart from executable Python code. Okay? This executable Python code, we are running it online, not on the local version of, you're familiar with Jupyter notebooks, IPython notebooks. This is the flavor of IPython notebook which we are running online. Google is providing that, Google is providing us a space to run our code, but with a small constraint. That constraint is probably roughly 12 hours of uninterrupted compute time. If you have your code running for more than 12 hours of time, the instance there will restart. So all the allocated resources to you will vanish. Allocated resources in the sense, one is probably can you zoom out and show them the time part in that. Command line, so from there. Okay, so basically in your collapse you will see something called as connect to a virtual machine. Virtual machine instance, all the hardware right now that you have is on local systems. Be it your CPU, be it your GPU, whatever processing compute power is there within the system in front of you. But this, it's being hosted in a virtual environment. It's being hosted in the servers of Google. On the go, when you are trying to connect to one of that will provide you with a certain amount of compute power. 12 GB of RAM, some NVIDIA graphics card, probably decent, what is the graphics card? K80 graphics card. What's the RAM for 12 GB? 16 GB. So yeah, 16 GB of RAM and a good CPU, probably what's the CPU? 10 cores? So you're basically getting a CPU, a GPU and a good amount of RAM for free, but with a catch of 12 hours of runtime. If you want to extend that, there is another option called as Colab Pro, but I don't know if it is available in India yet. So, it is there, but not sure if it's valid for our IP addresses. Okay, that is one thing. The advantage of it is that you don't have to install libraries within your own computer. The thing is, when you're working on multiple projects, let us say OpenCV particular version to 3.4 or something, and the OpenCV version is there. For my other project, I might need an OpenCV outdated version or a newer version. The conflict of versions wouldn't arise. Again, spending more time to resolve those conflicts. How many of you here are familiar with Docker? Docker? Familiar with Docker? Okay, let us not go into that direction. Basically, simply put, to avoid installation issues in your laptops, in your systems, Colab is one of the best possible way that you can get to execute the code. Okay? So, can you once again connect to the runtime? Connected to the internet, laptops connected to the internet. So, once connected to the runtime, once you start writing sumo and what. Yeah, okay, exactly. You get that. You have some grams and the space. You get that. Yeah, include it. So we can just stop this one. Here, basically, treat this as a new system allocated to you. Whatever libraries that you want, you have to install. And the catch here is, once you close the system, once you restart the instance, once you close the browser and open it again, every single time you will be allocated some random instance and you will have to install all this again. That is only a catch. But it takes only a fraction of time. So, run this. So, this probably I am not going to explain you each command like you are in, but just to give you an illustration, this any command line from any code which is belonging to some command line execution, you start with exclamation mark in column and it will any installation command. Okay? I am installing OpenCV. OpenCV is a popular library for computer vision. The state of the art though is some other deep learning architectures, but I want you to experiment with OpenCV, then move on to deep learning architectures. Don't directly jump into deep learning architectures. There is a lot of scope here in understanding how an image is featurized. Someone was telling CNN, right? Who you're telling CNN, so someone else was telling CNN. You're telling CNN, yeah. So not just CNN, there are other techniques to feature images. You can extract features from images, and that is covered in this notebook. And probably this is shared, right? You can all go through this notebook later. Story on, we are all only just installing certain libraries of image, space, and all those things. So this is, I guess probably you all work with Matplotlib, standard library. Okay, cool. Avoiding involving generalized code, just where it will pop up. And yeah, so all these are random OS, OS, CPU, and when you execute that cell particularly, what that cell is basically doing is, it's connecting, it's taking a permission from you to connect the Colab instance to your Google Drive. Why Google Drive? That is where you have stored all the files required for this problem to work on. Once you give it permission, this line, this particular line, you are mounting your Google Drive. Probably anyone has worked with Linux, would be more familiar with this. Okay, cool. Once you are mounted to Google Drive, you have access, this particular instance has access to all your data in the Google Drive, and now this So all these things that you see here are basically hyperparameters. How many here are not familiar with the word hyperparameter? Okay. Anyone else is familiar with the word hyperparameters? Can anyone name any hyperparameters? Some algorithm that they have used. Any hyperparameters? Someone can picture any names of hyperparameters?
Neural network, intelligent learning rate, number of layers,
Okay.
momentum.
Okay. If you go a little bit back towards ancient economic machine, start with simple things. Don't directly go from the start with simple things. Machine learning, any algorithm, any hyperparameters that you guys remember? Sorry? Okay, what is a hyperparameter there? KNN is an algorithm. What is a hyperparameter? Number of neighbors. Number of neighbors. So K is a hyperparameter. K neighbors, K is a hyperparameter. Okay. Any other thing? Any other algorithm that you know? Quickly, come on. Any other algorithm? Lull distribution, negatives, random forest, station trees.
The optimizer we use for neural network.
Okay, I just see the audio. Okay, yeah.
Optimizer we use, and in the SPM also we use different standards.
Okay, so basically, simply put, after a lot of experimentation with the data, for all the algorithms that you are applying within the data, there will be certain tunable parameters. Which tunable parameters are values which work the best, you will figure out at the end of the experiment, and then I put down in the starting. I want, whenever you are playing with this notebook, I want you to clear all these parameters. And yeah, so before scrolling down any further, there will be 3 levels of matching system used in it. Searching, 3 levels of searching. First, as you said, it's a histogram matching. RGB histograms are, RGB histograms are created. You have a query image. Now, what is a histogram? So, I'll tell you the entire flow first, then probably we'll go into step by step. First flow would be take a query image, RGB histogram. Okay, you get certain values. Beforehand, before you start creating any images, you build your database. How do you build that database? You have, let us say, 1 million images. You calculate the histograms of all those 1 million images beforehand. You store all that histograms in your database. Okay, you summarize some storage server, something. You store it along with the book details. Let us say book image is there, the ISBN number of the book is there, and the histogram details of the book is there. You have 1 million images with all the histogram details. Now you compare this query image of histogram with that, but the trade-off here is it has to be very fast. It has to be very fast. Even if it's order of 1, it has to be very fast. If you want to improve the accuracy, like how accurately my query image is matching with the image in my database, the speed of it will reduce, and histograms alone won't work. I'll tell you why histograms alone won't work. After histogram, there will be another level of matching. Let us say histogram will eliminate roughly around 500,000 of images and left with another 500,000 of images, probably around 100,000 images maybe. Now the second level of matching system will look out for structural similarity in the image with the images and database. What do you mean by structural similarity? Let us say you have certain case cut for yourself. Let's say there is a table or something. There is certain structure within that image. It might be the tiniest edges which are naked eye cannot see, but features can be extracted. You will compare how similar structurally an image is with some other image, and there you will eliminate half of this. The third level matcher would be something called as shift features, scale invariant feature transform. There, what is basically doing is, you will take an image in different possible angles. When I am searching for it, I don't get the proper name image, standard image, we were photos only, I don't get it. Probably the guy will be crazy and take an image in every different possible angle. And to search that, the features that are extracted has to be scale invariant. It might be zoomed in version of it, it might be zoomed out version of it, it might be tilted, transformed, anything. The features has to be scale invariant. And that, my friends, would be the last level of matches here. But the thing is, instead of shift, you all can experiment with different types of CNN architectures to extract the features and compare. And don't stop at 3-level matching level. You will probably increase the number of levels in the matching system that can reduce the latency in the system. Okay, this is one thing. And yeah, so here are some hyperparameters required for it. This is correlation threshold for histograms. What is this? When you are comparing one histogram with the histogram of some other image, up to what similarity will you allow, will you funnel out to the next level? Let us say, I kept this threshold of 0.8 here, right? Any match exists, let's say this image has matched 85%, this image is 85% close to some image in the database, only those images will be moved up to the next layer. That is how this works. Now the problem with histograms would be, you might take the image of the book in a dark environment or a brightly lit environment, that would affect it. The colors would change. Now how do you calculate histogram? It's basically a count of pixels. Every pixel, let us say, is RGB, right? And each of that ranges from 0 to 255. So if you take an image of 256 by 256 image size of an image, roughly how many pixels would be there? 655. Okay, that many number of pixels would be there, and you are basically calculating the count of each pixel. That is what an histogram is like. If you scroll down, and this part, this is basically a writing function. What is it doing is just loading all the images in my training data set. Let us say there are 1 million images. I am using roughly around 750,000 images for my training. This code is probably just loading it, and this is the code for histogram. So let's do a quick Google search here. I want you to understand how particular function can be applied here. Let us say this calculate histogram function is here. If you see, it has a huge number of parameters to it. It might be confusing what exactly it is doing and all these things. Break it down. Just search CPU calculate this function. Just type CPU calculate. Yeah. Now open the file and search now. The top. Yeah, this one. Guys, PyImage Search is a brilliant website for OpenCV. Adrian Roosevelt, probably the founder of it. This guy is shining it, right? It's really good with computer vision and is one of the most brilliant open source material available out there in computer vision. A lot of experiments to learn from this guy. And to scroll down a bit, there is OpenCV calculator function. Can you zoom into it? Yeah. So break it down. Earlier you saw so many variables attached to the function 0, 1, 2, 8, 256, 256. N number values are assigned to that function. Don't get scared seeing such code. Whatever code, trust me, whatever code you're working on in your college as of now, it will only be 1% of the code that you will be working on in the industry. In industry, there will be thousands and thousands and thousands of lines of code for one particular project. And it won't be in a single page that most of you guys in college would write. It would be modularized. There are certain set of standard coding practices followed in industry, which are apparently not much focused in college. Okay? So, many people will be working in the industry on that particular project. People will come, people will go, but the project will be properly documented. And it can be written well only if it is following a standard structure. Anything that you write, just do a quick Google search. See on what is being explained here. This is the images. It is even the image that you want to, the path of the image, the channels. A detailed explanation is given for each and everything here. I want you to familiarize yourself on how to use Google to the best possible extent. When you go into interviews outside, see, long gone was the era where people were just asked to bluntly memorize the entire code, CV2 code, this, that, and 100 different codes. Long gone was the era. Right now, what people expect you is, you should be able to write the logic, something which is agnostic to the type of code, something which is not dependent on the programming language. You can write the logic, you can write the flow of the program in a simple C language, Python, any number of things. But that is something that has to be built with you. Don't be language dependent. Try to understand how to search on things for functions quickly, how to get documentations. Start developing the habit of going to function documentations. Okay, this is one of the best sources, best ways to develop more efficient code. And how many of you here are familiar with Python programming? Show of hands. Everyone? Everyone? Yes, no, maybe. And okay, at least one programming language apart from Python. How many of you are familiar with? Okay, and what is it? Is it Java? C? Java. Okay. And okay, so irrespective of that, since everyone is using Python and we common to Python, there is something called as Pepade standards. Okay, you can just probably Google Pepade standards too. Whenever you are writing code, try to follow this Pepade standards. Just as I don't hit anything. If you see, you will have this Pepade tutorials in Java and you have some Python organization. You will get n number of blocks here. There will be so much of jargon, but somewhere hidden there will be a small gem of a block where some lazy guy wrote in short on what Pepade is, on what exactly we have to follow. A quick Google search will get to that block, go through that. Lazy guys are helpful at times. Go through that block and follow that structure in your code. There will be certain indentations, certain type of camel cases or certain type of cases when you're naming a variable. Go through that, make use of the standard structure. That is really good. Okay? And back then in college, I had this wonderful habit of naming my variables as var1, var2, var3, and I would end up naming var143. And I wouldn't remember what var1 was when I started. So, don't do that. Don't scroll code like that. Start learning Pepade. Okay? That is something that I would like to ask. Go back to my code piece. So, this block of code that you're seeing is just called histogram, calculated histogram function. And to compare this compare code and this histogram. Yeah. You will read in a bunch of files and you compare the histograms to all that. Now, this code is just to plot the histogram. Let us say, I have again considered this creature here, Elon Musk. Scroll down a bit. This is the image that I am plotting. Yeah, so this is the image that I am plotting, and this is the histogram of the curve. So, yeah, this is the histogram of the curve. So there are 0 to 255 pixel values, and R, G, B. the pixel counts. Okay, each of the pixel counts are mapped. This is how the histogram is plotted up here. To scroll down, what I'm doing basically is I'm creating a pickle file. How many of you here are familiar with pickle files? Familiar? Anyone else? So pickle files are again something for lazy guys like me. What they do, I once calculate all the histograms, I save them into a file, save them into a pickle format. Pickle format is nothing but a specialized file format to save the values from a Python program. So once I save the file, the basic useful thing is that anytime my instance restarts, anytime I use some other computer, I can just directly load the pickle files. I don't have to calculate the histograms for my 1 million images each and every single time again and again. So that is the use of pickle files. Invented by some of the lazy guys. Yeah. So scroll down. This here I am calculating the histogram of the query image. So basically my query histogram data is also stored in a pickle file because I ran this notebook earlier. Yeah. So to test, how many images I told you, right? Test and train has split the data. The thing is, I'm not running into that for 1 million images, guys. I'm just taking a small subset of book category on science and science fiction. So there are very few thousands of books in that. So roughly around 16 or something, I kept us testing it just as a demo purpose. You can always feel free to play around. You can always feel free to spend 2 more days to download the 2 lakh images, as I said. But it's totally up to your patience. So if you scroll down, you can just come down from these histograms. What is basically doing is I'm checking how efficiently am I filtering my histogram results. Am I filtering all my useful data also. Let us say out of 1000 images, in the first level of matching I'm removing 500 images. In the remaining 500 images, is my query image present? That is what I'm checking using my train and test data. Okay, probably we call it as cross-validation data. How many of you here are familiar with this words, train, test and cross-validation? Please show of hands. Anyone? All of you have done linear regression and logistic regression, I guess it was covered in academy, right? No code was run on it. Only theory. Not in a single line of code was executed. You have executed. What about everyone else? How many of you have executed code on logistic regression and ran some simple basic model? Show of hands. Raise your hands. Yes, no, maybe. Okay, and in that have you encountered something called as train cross-validation? Yes? No? Yes, no, maybe? For everyone the theory was covered, but only few of you have executed the code. Am I right or am I right? For theory, how many people have covered just a show of hands? Completely raise your hands, not half. And out of you, keep your hands up, out of you, who has not executed the code on the theory that you have learned, just drop your hand. Okay, only few people executed the code. Okay, that's strange. Okay, cool. So, if you execute the code, you will understand the differences of train, test and series. What you learned in theory and how you are applying it in practice, there is a difference. Okay, so in that case, I'll rather speak to the code because I was expecting some fundamental code being executed by you guys from the college. So most of this code depends on certain fundamentals that you have already learned. I rather skip through the entire language and execution and just give you the blocks. You can probably go through this documentation and understand what each and every line is doing. I'll also give a link to one of the blocks I wrote on this, and you can probably understand from that. It's like a step-by-step tutorial. Okay. So we'll quickly stay to this code blocks. So this is the block. This one, as I told, I'm calculating the structural similarity between indexes. Structural similarity between images. How similar in structure is my image? Again, I'll put some threshold line. If the image is more than 70% similar, then okay, funnel it out to the next layer, or else remove it from that layer. That is the second level of matching. Now, scroll down. Just scroll down. Okay. So at this level, it is showing roughly around 93.75 accuracy. What does it mean? Accuracy again might not be the metric depending on what you're looking at. So here it is telling me that out of 100 images, for roughly around 93 images or 94 images, it is correctly filtering out into the next layer. But for the remaining 6 images, this particular filter is screwing up. Even though let us say my Elon Musk book is there in 1 million database, but at second layer, it will remove that. It won't show it at the end. So it will basically return a mismatch kind of thing. Okay? That's okay. Can you go to the next one? So once this is it go, not once, this is it go. After setting, someone here has told me a 10 years labor approach. You told me 10 years labor approach, right? So this is a flat nearest neighbor mapping, center nearest neighbor mapping. Okay, we are extracting features within Swift, and this can be replaced with anything that you want. You want to use CNX, use it. You want to use any other algorithms like Swift or any other variant, feel free to use it. Manish, just scroll up to the Swift feature up. Yeah. So replace the Swift with any other algorithm that you want. Run the code, and same thing with Flan. See, there is two different things here. Whatever algorithm you are using, there are two approaches. Either to calculate on the run or to calculate and store it beforehand. Since it's like a pet project for most of you, and the data might not, the hard disk size might not be enough at times, or RAM size might not be enough at times. What here has been done is basically you are calculating on the go. Let us say in the final layer, Swift layer, I am calculating Swift features for the query image. And from my previous layer, it has told me, okay, you have 10 images in your database which are close to this. Probably your query image is 1 and this 10. So what I am doing here, I am calculating my Swift features for all those 10 images. And then I am matching it. The alternate approach for this, however, would be store the Swift features, store the histogram data, store the structural similarity index matching, everything in your database, and that could avoid a lot, that would save a lot of runtime, They're not computing each and everything again and again. That is one thing. So once the features are obtained, we are mapping that, we are projecting that into a high dimensional space. There in that high dimensional space, we are using some flavor of nearest neighbor algorithms to get the closest point to my query image. And that, if you scroll down, there is something called as loss ratio. This guy is basically made huge advances in the nearest neighbor algorithms using Flan and SIP, and there is a name it after a parameter, which is basically somewhat the distance. Okay, you can tell that if it is 1 kilometer far away from you, that is close to you. That is sort of what we are defining here. The term will have to here 1 kilometer, but I am just giving you a rough example. Okay, go down and scroll down. Basically, at the end, you will finally give a query image of Elon Musk, and from your data, you will fetch that. How is it matched? There is one more thing, guys, top 3 predictions. What is this? You can measure the accuracy of your system in multiple ways. You can either tell me, whatever image you are telling me, this is my matching image, is it correct or not? Or throw 3 images at me, in the top 3 is the matching image present or not? Or in the top, that is something like that. Okay? And scroll down. Scroll down further. So this is my query image. Scroll down. Read this book, by the way, it's a very good book. Elon Musk by Ashley Vance. Very good book. Scroll down. In my database, scroll down. Just I want to see these scripts. Okay? In my database, I have 3 different versions of the same book. Okay, one with the name written on top, one with the name written here, and one with a single script. Okay? If you scroll down, you can see the closest matches are this 364 key points. Key points, this is in an image, each like just this dot. Okay, yeah, these are the key points. All these key points are being matched. The Swift feature algorithm will give you all these key points, and each of these key points is being matched, and you have 364 matches with that image. So, from the database, you can extract the ISBN number. Right? After getting an ISBN number, scroll down. As usual, scrape the data, whatever is available on the website. Goodreads.com is a good place for getting book reviews. And at the end, you can get the entire rating of the book, and the book description, everything. This is what the entire flow of the project is. And an advanced version that I made for this is an app. You take an app, Android, iOS, you can be very specific to the version that you're using. because there is something called as ML kit for the iOS versions of the app, and for Android, I don't think I work with Android. So there is some layer of things for TensorFlow, like here like for Android. Basically, you can make an app, click an image, just get the results. Try making that as a pet project. You know, you can pick up our development from few websites, tutorials. New Boston, there is some good tutorial place on YouTube where you can pick up tutorials on several different things. Okay? And freecodingcamp.org also provides good tutorials. This is the overview of this entire thing. Okay? Just go back to the slides, probably 10 more minutes will after this. Just go skip through this, go here. Next step. Up, previous slide. This is something that I am going to give you access, online access to each and every one of you here. This is just an online access for the workshop. Okay? I'll probably take a student coordinator from here and send him the details on how to register, and we'll share the details with you. All of you will get roughly around 6 months of access for this workshop. There will be certain videos specifically related to recommendation systems, and you can experiment with the code given there to make a small recommendation system. Okay? And yeah, this code. So basically, probably, so if you search anything in Amazon, let's say Talks for Women or something like that, you will also be recommended certain things. Like certain recommendations are given. How are this recommendation given? How are they tell you this is sponsored products, okay? But something related to this item. Back then, a decade ago, there was this concept of sponsored products at Amazon, but they were showing some bullshit results. Even though it's sponsored, someone is just paying money to show them the results. User wouldn't click on it. Why? Because it is not relevant to it. So that has to be improved. The relevancy has to be improved. And there are two different ways. Probably next slide is the task basically in the workshop will be, you will give an image, you will have credit on the similar images. Recommend similar stuff. How the recommendation stuff is done? Next slide. Next slide. There are these 4 ways. Bag of words, someone heard basics? Anyone? Bag of words, vectorizer, text vectorizers, show of hands. No? Okay. You guys have already started with the deep learning part in theory, but machine learning part is done, and you haven't covered bag of words in there. Brilliant. So, yeah, so this is something very basic in that. Whatever text you are seeing here, to convert it into numbers, you need certain types of basic algorithms. Those are bag of words or some other vectorizers that you can find, okay? I can recommend you an item based on 2 things. One is content-based recommendation, other is collaborative. What would it is? Content-based. Let us say I am recommending you a similar talk. I would extract all the features from the talk and I would recommend you the similar talk. Collaborative again would be sort of different. There what happens is, let us say I am looking at certain books, book 1, book 2, book 3, and my friend Manu is also looking at certain books, book 1, book 2 and book 4. Now other colleague is looking at certain books. If he sees book 1, then automatically book 2 is also recommended to him. Because anyone who is seeing book 2 is seeing book, anyone who is seeing book 1 is also seeing book 2, right? You understood my analogy, right? So that is one type of recommendation. The second type would be extract information from the user. What kind of user? If someone is similar to me with my attributes, then show them similar stuff. Okay? That is basically the entire goal of this workshop, to work on recommendation systems. And take this in collaborative resource. I will share the registration details later in this slide. Okay? Yeah. So, guys, there is a lot of demand in the industry. 700,000 jobs is not a joke, and yet many people from the college are struggling to get jobs, get back jobs. That's not the right way. You see the gap where you covered machine learning, entire syllabus, and deep learning you are going to start, and you haven't covered fundamental differences, something like barriers. And even though you covered algorithms, you never put them into code. That's not how the interviews work. That's not how something the real world expects. So there are job openings outside there. Prepare yourself in a way. There are certain sites like Kaggle. How many of you here are familiar with Kaggle? Good. And how many of you have tried something on Kaggle.com? Any competition? Okay. What was the competition? What was the competition that you tried? You raised your hand. Okay. What was the competition that you guys
Competition from Indra.
What is the data?
Images.
Images. Okay. Anyone who here worked on text? Anyone who here worked on text data? No. Kaggle has n number of competitions. There is a text data, there is. Sorry?
OCR.
Okay. Yeah. Okay. Good. So Kaggle has n number of types of problems. Explore them. There will be a detailed something called as kernels, notebooks, where other people have explained their solution, why something is working, why something isn't working. Whenever you are learning an algorithm, always remember three things. One is, you learn something, understand when it fails. Not only why it works, understand when it fails. Like you said, k-nearest neighbor algorithm, you need to know why it fails also. What are the boundary conditions that it would fail. The second part is, implement it. Implement the algorithm, not from, like, there will be something. If you can implement the algorithm in pure Python code that you have learned, then you have understood the algorithm in and out. If you are able to replicate KNN algorithm, basic KNN algorithm, you understood KNN in and out. If you are able to replicate logistic regression, linear regression, that's miraculous, you know. You will remember it forever. The third part is to use this in the real world scenario. See how the results would fare in competitions. Most of the Kaggle competitions, one common algorithm that you would observe though is XGBoost. How many of you here are familiar with boosting and bagging concepts? Show of hands. How come you are familiar with so many concepts? Man? It's in the academic or your reading? Good. Okay. So I see a lot of gaps in the academic and students. I don't know why. So that apart, three things. Learn the algorithm, its pros and cons. Code the algorithm. Third thing, apply the algorithm in a problem stating something like Kaggle. Okay? And build your basic machine learning skills. After that, you can start with basic programming skills. Any interview that you give, initial round would be on STE. They would expect certain amount of algo and DS from you, algorithms and data structures. Don't put aside this theory, you know. I'll tell you something. Algo-DS is sort of less theory and more hands-on coding, but machine learning is most huge amount of theory and less amount of coding. That's a problem. We forget things. Match these two things. Probably, when are your placements? In next 6 months? Next 6 months, if you are aiming for companies that care only about Algo-DS, then use sites like LeetCode or something. Familiarize yourself with the algorithms for the companies that you're aiming with. You need not start with a 4-month freelance textbook and read from start to end. Narrow down, start from small. Some sites like RLExpert or LeetCode. Start from basics. Don't always rush to the top or straight up at Start from basics. Develop yourself in programming and basic logic building. That is very, very, very important in cracking the jobs. Once you are good at that, parallelly spend some time implementing the machine learning algorithms, provided you want to bag some machine learning jobs or some ML a couple of your plans for recruiting. Okay, so this is it, and probably my colleague and your senior Manoj might want to speak a few words and conclude this workshop.
Okay, guys, as Karthik said, like, bridge the gap between the academic syllabus and the industry actually. Okay, so as Karthik said, be good with the coding part and be good with the computer science concepts actually. Computer science concepts in the sense, be good with the databases, operating systems, each and every theoretical part and each and every core part that you are learning in the computer science is very much important in the industry actually. If you learn those things, it will be very much easy to build state-of-the-art systems. It will be very much easy to do some kind of system design in the real world. And I think coming to the machine learning part, be good with the stats part. Okay, I hope you have covered the stats part also, like the PDFs, CDFs, everything, different kind of distributions, and people are generally building state-of-the-art machine learning algorithms with the help of statistical models itself. rather than going with the machine learning algorithms and deep learning algorithms. So my suggestion is like, be good with the statistics part and theoretical machine learning part. If you are aiming for big companies like Amazon, Netflix, or Facebook, these kind of companies, be good with the theoretical part in the machine learning, and the coding part also is very much required. Both things are very much required. You can leave deep learning apart. Why? Because as your freshers, people will generally look into your machine learning skills rather than deep learning skills. Okay, don't run towards the state of the art things. Why? Because they are never implemented in the real time actually. A few companies like Google, Microsoft and Amazon will implement them. Rather than these three companies, or to be frank, the FANG companies will only implement this, and only there are few teams implementing these things. And other things are mostly will be working on the machine learning algorithms like classification and regression algorithms itself. So be good with the basics part, be good with the machine learning concepts and the basics of machine learning. I think so you can crack good companies like Amazon, because everything has changed in the past 4 or 5 years actually. Initially in our time, when we want to go to Amazon, they used to look at the degrees, like whether you're from IIT or NITs. Right now it's all changed. If you have capability, people will come to you, the companies will come to you to take you to that company. Okay, be good with the basics part, and I think most of you can be placed in good companies like Amazon, Facebook, Netflix. Okay, yeah.
So, just concluding on this, guys. One thing, whoever has given reasonable solution for the multi-stage filtering system, just tell my colleague here your email IDs, and probably by tomorrow afternoon or probably by today night, you will get the complete course access. We'll send you a detailed email on how to register for the course. The validity will be for 1 year. It includes machine learning, deep learning, and deep learning solutions. The